All right. So conditional statements, really easy thing. When you're writing a statement in if-then form, and that's the way we're going to write conditional statements. If-then statements, near and dear to my heart. Use them a lot in computer programming. Some of you have taken Mr. Schultz's class. I don't know exactly how much you use if, specifically the words if-then, some of the languages that you use in his course, but it's the same principle out of that. A conditional statement: if someone hits the number 7 key, then this happens. So when you're writing the language for the apps, you got if-then things. So if this happens, or if the user does this, then this is what happens with my app or whatever I'm writing there. So that same idea here. Symbolic form for that is going to be first statement we'll call P, and then it's an arrow, just a straight arrow, Q. And it's read as P implies Q. You can read that as if P then Q, or as P implies Q. And that's, I usually use the implies way of reading that, okay? So symbolic form is just a straight arrow there. There's a short arrow in between the two statements. The hypothesis, it's a lot like that. Yeah, it is. Is the phrase immediately following the word if. The what? Thinking about scientific method. Conclusion is a phrase immediately following the word then. If this happens, then this is the result. Okay. So when we're looking at statements, we're going to first take some if-thens and write the hypothesis and the conclusions. And then we're going to go the other direction. We're going to take statements and write them in if-then form. So start off with the easy stuff here. So identify the hypothesis and conclusion of these statements. It's super easy if it's in if-then form. So if you live in Nashville, then you live in Tennessee. So the hypothesis is that part, right? You live in Nashville. The conclusion is the part after the then. You live in Tennessee. Very easy if it's in if-then form. All right. Number 2, if the sum of the measure of two angles is 90 degrees, then they are complementary angles. So we kind of relate that to some geometry stuff instead of other things. So the sum of the measures two angles is 90 degrees, then they are complementary. Make sure you spell complementary correctly. An E instead of an I. All right. Number 3. If a quadrilateral is a square, then it has 4 right angles. So hypothesis is about the shape there. A quadrilateral is a square. So what does that mean a quadrilateral is? Well, a square has 4 right angles. What does it mean a quadrilateral is? What's it mean to be a quadrilateral? Do you have to be a square to be a quadrilateral? It's just got 4 sides, yeah. Super easy stuff there. Nothing exciting about that at all. Fairly boring. All right, so let's get into a little bit more interesting thing. It's still not incredibly difficult. We're going to take some statements And they're conditional statements as they are, but we're going to write them in if-then form, so it's a little bit clearer what the hypothesis and the conclusions are to these statements, okay? So the first statement says an obtuse angle has a measure greater than 90 degrees, all right? So a obtuse angle has a measure greater than 90 degrees, and I'm going to, go this route. I'm going to say if the angle is obtuse, then the measure is greater than 90 degrees. Why is that the correct if-then form? Why not say if the measure of the angle is greater than 90 degrees, then it's an obtuse angle? That's part of it. Are all angles that are greater than 90 degrees only called obtuse? No, you could have, if it's, what's another example? Straight angle. That's greater than 90 degrees, but it's, specifically 180, but it is still, technically greater than 90 degrees, but it has a different name besides obtuse angle. So being careful about that. Number 5, all numbers divisible by 4 are also divisible by 2. Okay, so what is the hypothesis for that?
If all numbers are divisible by 4, then they're divisible by 2.
So if a number is divisible by 4, then it is divisible by 2. Definitely. Why not the other way around? Is a number that's divisible by 2 automatically divisible by 4?
Yeah.
Definitely not. Number 6, states on the East Coast border the Atlantic Ocean. So if-then form. We're assuming we're talking about states here. So the United States, we have states. Don't have states in other countries. Not. So if-then form. Somebody give me the if-then form. Yeah, if a state is on the East Coast, then it borders the Atlantic Ocean. 7, let's just talk about it. We won't write it out. Valentine's Day is in February.
That's not true. Wait.
It's okay. You're living on the house. All right, so there's something about Valentine's Day. Valentine's Day is in February. So if-then form, just say it to them. We won't write it out. Yeah, if it's Valentine's Day, then it's in February. Then it is February. All right. 8, prime numbers only have 2 factors, 1 and itself. So if-then form for that. Yeah, good job. Yeah, very easy thing there. Nothing really hard about this at all. This is boring stuff. Inverses formed by negating the hypothesis and conclusion. An inverse negates the hypothesis and the conclusion. So negation is not P implies not Q. Remember we talked about negating in last week's lessons. So that put the not in if it doesn't have it. If it does have not in it already, you take it out. So it's the opposite, but it doesn't change the order. Inverse doesn't change the order. The converse is formed by switching the hypothesis and conclusion. So instead of P implies Q, it goes the other direction. Q implies P. That's a converse. And it doesn't change the statement. It just changes the order. Okay. So your hypothesis goes last and your conclusion goes first then. All right, then there's a thing called a contrapositive. A contrapositive is formed by negating and switching the hypothesis and the conclusion. So it'd be not Q implies not P. So the contrapositive is the converse of the inverse, or inverse of the converse, whichever way you want to talk about that. So inverse, negate both statements. Converse, swap the order. Contrapositive, do both, inverse and converse. Okay. All right, so let's take some problems here. We're going to write the inverse of the statement, the converse of the statement, the contrapositive of the statement, and the conditional, and then we're going to determine the truth value. And if it's false on any of each of those things, then we're going to provide a counter example of that. Okay, so the original statement is, if it is Saturday, then there is no school. So the inverse does what to both the hypothesis and the conclusion? Negates. So the new hypothesis would be, if it is not Saturday, then there is school. What's the truth value of that? Be false, right? The counterexample would be Sunday. Technically, we're talking about school like regular school, not Sunday school. Yeah. Different kind of school. All right, so again, the inverse negates both. So the original one had a no in the conclusion. So the negation of that takes the no out. The hypothesis did not have the negative word in it, so we put the negative word in it. Okay. The next one, the converse of that. Excuse me. What's the converse do? Switching them, switching the conclusion and the statement. So your new if then will be, if there is no school, then it is Saturday. Truth value. False. Could be Sunday, could be spring break, could be summer break. That any of those things could be definitely counter examples for that. The contrapositive does both of those. It's the inverse of the converse. So if there is school, then it is not Saturday. Truth value. I'd say it's true. We don't have Saturday school in McNairy County. Not yet, anyway. I'm not a fan of that. People want to do that. I don't want to do that. Like for detention, if you have too many tardies or something like that. No. If they do that, that's fine. I'm just not going to work. All right, number two. If the product of two, let's just talk about these. We won't necessarily have to write them all out. So let's just talk. So if the product of two numbers is odd, then both numbers must be odd. So the inverse of that. So what's the negation of odd?
Not odd.
Even. Yeah. Okay, even. So the negation of odd would be even. So the product of two numbers is even, then both numbers must be even. That would be the inverse. Or you could put both then the numbers are not both odd. Maybe you put the not in there if you want to. What's the truth value of that? The product of two numbers is even. Then the numbers are not both odd. That'd be true, yeah. Converse. Just swapping them, not changing it at all.
Then the product of the two numbers.
And the product of two numbers is odd. Is that true or false? Carson says true. I agree. Yeah, it's true. Contrapositive. Swap and negate. So if
Then the product of two numbers is even.
and the product's even. If we multiply two even numbers together, do we always get an even back? Pretty much, or yes?
Yes.
If it's false, give me a counterexample.
It's true.
Yeah, think. Don't just throw answers out there. Think. Two even numbers multiplied together, do they always get an even number? Yes.
Yes.
Think about two even numbers, 2n times 2x. That 2 times the number is going to be even, right? 2 times a different number is going to be even, right? If I multiply those together, that's going to be 4 in x, which could be written 2 in x. So that proves that that's even because it's divisible by 2. So yeah, that's true. That one had true all over it. Number 3, if the temperature is 25 degrees Fahrenheit, then it is below freezing. Inverse. Truth value. False. What's the counterexample? 26 degrees. 20 degrees. Negative 85. Any of those. Converse. Give me the converse statement. Quit just saying true and false. If it is below freezing, then the temperature is 25 degrees. That'd be the converse. Is that truth value for that? It's false. So counterexample could be any of those numbers that are below freezing that are not 25. Contrapositive. Give me the statement. If it is not below freezing, then it is not 25 degrees Fahrenheit. Truth value on that one. What's our conditional statement? Our hypothesis is that the number is what? The temperature is not below freezing. Okay, so our numbers that are starting, that we're testing with, the if part, are numbers that are higher than 32, right? So then the temperature is not 25. So are those numbers not 25? Yeah, so that would be a true truth value on that one. So when you get into doing the truth value on the contrapositive, it gets kind of twisty a little bit. It can turn you around there. So be careful of that. All right, so let's talk about biconditional statements. A biconditional statement is the conjunction of a conditional statement and its converse. The symbolic form is P implies Q and Q implies P. The shorthand of that is a double-sided arrow. Arrow going both ways. And the way we read that is P if and only if. Okay? And biconditional just means it works in both directions. Big fancy words and all that notation there just means it works in both directions. So biconditional are true when both conditional and converse are true. So it's got to be true in both directions there. Okay. So we're going to look at some statements that are not necessarily are not in the if-then form, and then we're going to talk about the biconditional stuff with those. So scroll in. There we go. Given the biconditional statement below, write both the conditional and converse and determine the truth value of the biconditional. Explain why or why not. Okay. So the first statement says two angles are supplementary if and only if the sum of their measures is 180. Okay. So writing that as a conditional statement. So in if-then form. So if two angles are supplementary, then the sum of their measures is 180. That's an if-then form. The converse is other direction. So converse does what? Switches them, doesn't change them as far as negation or anything. Negation is inverse. Converse is just swapping. So if the sum of the two angles, yeah, or of two angles, you have to put the in there. It's 180 degrees. Then they are supplementary. Now, the rules are to be true as a biconditional statement, if and only if. So, two angles are supplementary if and only if the sum of the measures is 180. The conditional has to be true, and the converse has to be considered true. So, is the conditional true?
Yes.
Is the converse true? Yes. So that means that the biconditional statement is true. So the conditional statement and the converse both have to be true for the biconditional statement to be true. Let's look at number 2. I wear my snow boots if and only if it snows. Let's just talk about it. You can write it if you want to. I'm just going to talk. What would be the conditional statement of that? Okay, if I wear my snow boots, then it snows. Okay, what's the converse of that? If it snows, then I wear my snow boots. Is the conditional true? If I wear my snow boots, then it snows. If that were the case, I'd say wear your snow boots. So that the conditional is false. which automatically means what about the biconditional? It's false. So false. And explaining would be the conditional was false. We know to be true as a biconditional statement, you got to have both conditional and the converse being true. It doesn't matter what the converse was. We can go ahead and talk about it. If it snows, then I wear my snow boots. I would say, I guess that technically would be true. It is for us, considering where we live. You don't own, most of us don't own snow boots. Some of you may, most of us don't. But anyway, yeah, so that's a weird thing to do. But the idea here is that the biconditional is false because one of those is false. It doesn't take both of them to be false. Just one of them is all it takes. The conditional meant that. So look at number 3, a little bit more mathy, a little easier to deal with here. X squared equals 25 if and only if x equals 5. So the conditional statement. Okay. If x squared equals 25, then x equals 5. Is that true? 5 works in the equation, right? The converse. If x equals 5, then x squared equals 25. Is that true? Let's go back to the conditional and see that again. If x squared equals 25, then x equals 5. So the conditional, the if part is the hypothesis that x squared is equal to 25. Is 5 the only answer to that? I hear no and yes. I heard a no, and then I heard it change to a yes, and then I heard yes. How do you solve x squared? To take the square root of a problem. I put the square root in there. What else do you put in? -5 also an answer. Because the x squared equals 25. When you solve that by square roots, you got to put the plus or minus in there. So that means x equals positive or -5 as a solution to that. So the conditional in this case is false. Okay, so the biconditional has got to be false. And remember, just x equals -5 is how that's happening. Okay. Number 4. If we get, or I will get 10% off if and only if I spend at least $75. If so, conditional, if I get 10% off, then I spend at least $75, right? And then converse to that would be if I spend at least $75, then I get 10% off. Are those both true? I get 10% off, then I spend at least $75, and then the other one is true. So this one is true. Both of those make up true. All right. So let's do a little graphic organizer there as that last page. The mind your P's and Q's things, just a way to keep you thinking about these. And the notation is the big thing, just to remind you of those things. So here are our statements. P is vertical angles are congruent. Q is 15 is a prime number. And the conjunction of those two things. So what's the notation for conjunction? Yeah, conjunction is what word? And. Okay. So P and Q. What's the notation for that? Little house top. Yeah, that's right. Little house top for and. When if you were going to write that statement out, you would write vertical angles are congruent and 15 is a prime number. What's the truth value to that?
true.
15 is not a prime number. When you're dealing with and problems, how many of them have to be true for the statement to be true? Both of them do. So this one is a false because 15 is not a prime number. So that is definitely not both of them being true. What's a disjunction? Or. Okay, so these are ands. This is or. Okay. So P, what's the notation? Yeah, the V, the upside down little housetop thing there.
It's true.
Why?
Because one of them is down.
Yeah, all it takes is one for the or problems for that to be true. Okay. All right, conditional statements are changing on the next ones here. P is if it is St. Patrick's Day. Q is it is March. She didn't know. St. Patrick's Day is March what? 17th. Okay. So conditional P implies Q. So what would that statement be? We're just writing that. If it is St. Patrick's Day, then it is March. So would that be true or false? True. The inverse, the notation for that was a little squiggly. That's fine to think of it that way. Yeah.
But I want to be a regular line, like negative, not just world.
Not P implies not Q.
It's false.
If it is not St. Patrick's Day, then it is not March, and yes, it is false. And what does the converse do? Switches them. So it's just Q implies P. So if it is March, then it is St. Patrick's Day. That's false. It could be my birthday or something like that.
Your birthday's in March?
Absolutely.
Really?
Every year
Okay. I didn't know.
on my birthday.
What day?
What's that? What's that? Contrapositive. What's contrapositive do? Yeah, it's the negation and the swap. So it's an inverse of the converse. So not Q implies not P. Inverse of the converse is the contrapositive. So if it is not March, then it is not St. Patrick's Day. If it's not March, then it's not St. If it's not March, can it ever be St. Patrick's Day? No. So that would be true. And the biconditional. And remember, that's the double-sided arrow. P, if and only if Q. So it is St. Patrick's Day if and only if it is March. So
that's true. So
it's got to be true both directions.
it is. Oh, it's not.
The conditional and what else has to be true? The converse. The conditional and the converse have to be true. The converse in this case is false. So that makes the biconditional false out of that. So remember those rules about the conditional and the converse for the biconditional. That's the key. Okay. So writing out those statements, this is the if and only if. Make sure that you're using those words when you write out biconditional statements out of that. So tomorrow we'll have a quiz that'll cover this stuff and then what we did on Friday. And, so and then we'll get into the proofs.